recording has started.
Excellent. Thank you very much, Nils. Me and Ove will present ourselves before we deep dive into the details or the presentation, not into the details of IMF, but give you an impression of what it is and how we will be using it in the industry. Ove, you can start with your presentation.
Hi, my name is Ove Heitman Hanssen. I'm working in DNV. My main role is a global responsibility to create a standard and best practice, how we can create digital trust. That goes for information modeling that we're going to talk about today, but also digital twins and data quality as such.
Excellent. My name is Jann Slettebakk, working in Aker Solutions. Have a role there as interoperability architect, being involved in things like we are discussing today, how to get data shared and get an interoperability both inside Aker Solutions. We have several systems that need to talk to each other, but also outside Aker Solutions with partners and vendors. Okay, the heading for our presentation today is IMF for the OBI IDO community, and we have a subtitle that says Trusted Asset Information Models that is machine understandable in a life cycle perspective. The figure you see below there indicate interoperability and standardization. Could be the other way around as well, standardization and interoperability. And the partners in this work is Equinor, AkerBP, Able, and Aker Solutions. And we are working closely together with Veritas, like the team around Ove, PostCesar, and other organizations. We plan to do the presentation in approximately 40 minutes and leave for some Q&A after the session. But if there is any clarification you need to do during the presentation, raise your hand and Nils will help us to stop me.
Or put your question into the chat as well.
Or yes, put your question in the chat. The agenda for today is introduction and background drivers for the work we are doing. And we are introducing something called the 3 pillars of the IMF validation. We will come into the information modeling framework a bit more in detail, but still on a high level. And in the end, we will go through the digital asset, the full ecosystem, and the life cycle perspective of the IMF. First, I will also, hang on a second, I have selected the wrong slide set here. Let me change that. So before I dive into the details, DISC is an organization with an objective to achieve a seamless, standardized, secured, and verified data flow. And this to accelerate project execution and streamline the operational process of for greater efficiency. It's a mouthful, but I think you get the idea here. By standardizing, by having seamless interoperability and secure verified data flow, we also will get more help from our computers and digital technology. Background. We have for years been struggling getting out of the document challenge with respect to the data flow.
Det var så som de når jeg prøvde å komme med noen kommentarer om hvor kult det var med
There is
kunstprosjektet hennes.
somebody making or talking with the open microphone. Could you close the microphone, please? Yes, this is the background. We want to get away from paper-based information handover and information flow, where, as it is today, the main transport mechanism for information and data is by PDF document. All the way from the concept and the DG0 all the way into the operational phase of a plant. And this tagged line of indicated with the gray area here indicates the loss of quality, the loss of data between every step or every organization you have involved in your project execution. And this is also something we want to attack and improve and get into a situation where we can have a more smooth data flow and a smooth transition from a concept development to the operation of a plant. This figure is also illustrating the concept behind IMF, where you have the functional requirement indicated in yellow, the product aspect indicated in bluish, and the location aspect in pink. There might be more aspects that we need to fulfill a complete project and plant, but these are the three we have focused on now in the beginning. And you see in the beginning here, the functional requirement is normally bigger or have more data than the product. You do not select product until you have the functional requirement in place. And it grows as you go out into the studies and into the feed. But maybe then in the feed and transition to detail engineering, you will see the selection of product be more dominant. And then you move into product selection, you move into data exchange and interoperability between the different stakeholders in the project. And in the later phase of the project, you will have an operational plant as well. So you will get data from your sensor that is connected to the plant design. And the philosophy we have is to build this with the connection to the ontology-based interoperability and the industry data ontology that refers the OBI IDO letters. This is an illustration of the traditional V model, where you get the design basis, you get the required product project requirement from your client. They are normally refined by some bodies in the engineering procurement process, a EPC company or similar. It's refined, detailed out, and the specifications are going further into the vendors organization, and they are continuing on into the manufacturing process, and data and products are coming back. And we would like to see data coming back that might be validated, so the vendor can validate that their product specification has been followed by the manufacturer and they can digitally verify that the manufacturer has delivered according to the agreement. Same goes with the EPC company in the engineering and procurement process where data is coming back compared to the specification that was given down the value chain, and further up again to the owner operators where they can digitally validate by shackle or other means the digital information they get from the vendors, from the EPC and into operation. I don't want to go through all the text on the right-hand side. You can read that. You will get a copy of these slides later. We have also been looking into the naming and the names the industry are using on the different products and different activities that they are doing in a typical EPC project and into the operation. There is some generic attributes, there is some location attributes, there is some product attributes, etc., etc. And we have all names to these attributes. The unfortunate thing is that we have different names. One company can call it a note, while other company can call it a remark, other company can call it a long text. And this is hard for the computers to interpret. We need to agree on a naming convention and a naming standard to get a more consistent flow, consistent design, and interoperability with the data exchange. And this is what we are trying to attack. We have also established something called the 3 pillars of the IMF validation, and Ove will take control and go through that presentation.
Thank you, Jann. As Jann said, there are some kind of prerequisites that need to be in place, and I'm going to just highlight those pillars that we have put in place that we need to be in compliance with if we're going to succeed creating a digital trusted asset. Can you take next slide?
I think you had control. It was just to click, Ove.
But it's not reacting. There we go. So I'm just going to give you a high-level introduction. So see what we're working on to make sure that we can create asset information models. So first of all, we need to contextualize and serialize, as mentioned by Jann. We need to create a persistent IDs, understanding what actually we're dealing with. Then, of course, with these 3 green pillars is the foundation that we need to have in place. And as you see from the left to the right here now, we need to create structured entities based on object information models, create using an ontology that is knowledgeable. We pointing at the OBI and IDO as that approach. And we need some rules and constraints as mentioned as shackle example in the beginning. So those 3 pillars need to be in place if we're going to create a trusted information model. And that's what we're using all the way along when we create information modeling and follow the information modeling framework that we're going to explain in more details. But all 3 need to be in place, and we need to validate those 3 pillars in place to make successful information models. So just a quick introduction into this. There's a lot of things behind the scenes for those 3, but for this community, it's important to know that we pointing at OBI and IDO, the standardization, the work you're doing in these working groups. This is the fundamental thing that need to be in place. So Jann, take control.
Yes. I will then go into the IMF the information model framework a little bit more in details. But before we go dive into that, I will also like to emphasize the move we are taking from more maybe mind models, graphical models, objects model into machine readable and processable models, and achieve a machine understandable model following the OBI and IDO as Ove says, but also hopefully get along with the automation ML, the DXP, the GForce, the Industry 4.0, and connected to the upper ontology. The IMF, what is the IMF? The IMF is a method, a framework, and a language that allow creating an engineering-friendly description of a facility asset. And as you saw, using graphic figures and common industry reference data, reference data libraries. The libraries contain definition of elements, IMF types, that are frequently reused. The resulting information model of the facility asset contains then information in a format which is readable to humans as well as computers. And we have tested this out now in the Yggdrasil project, and we see that this is working. It's the minimum viable product for the time being, but we are working hard to extend the library we have established in post-CSR. This, I can hear somebody talking again, so please mute your microphones. These IMF aspects is also important to understand, and they're following the IEC ISO 81346 principle, and IMF is also based on the IDO OBI as we said. And we are following the functional aspects, the product aspect, the location aspect, and the operational aspect. Illustrated here by the yellow, pink, and bluish colors. This is also illustrated with, in this context, Lego blocks. So maybe you can think of parts of the IMF types as Lego blocks. Covering the functional aspect with its attributes, following the product aspect with its attributes, some attributes then for the location aspect of an object. We have also played around with another aspect because we need more aspects, and we are currently playing around with what we call the plant aspect, to fulfill the IMF block for an install aspect with its attributes. And this is something that AkerBP now is testing out, and Equinor have been an instrumental part in defining these current blocks that we and aspects that we have. We have tested it out on quite a few data sheets, taken traditional data sheets and dismantled them and established the IMF types with their IMF blocks. Illustrated again like this with Lego blocks and the different aspects, the aspect terminals or the IMF type terminals and connection points with cable connections, process connections, and other type of connection elements. An illustration of indicating how a temperature transmitter is connected, and this is implemented in the PCA library with its temperature transmitter, which includes the sensing element, the thermowell. It has an instrument house with the temperature transmitter includes, and it has a connection cable connection in this instance to an electrical actuator. Connect includes an control valve. And this is in layman terms. This is includes and cable connection. It could also be written in IDO language. Has terminal cable connection on the instrument housing, and the same goes with the electrical actuator, and has a part control valve. So then you see the utilization of the IDO in the context of IMF. We are not talking about products only. We are talking about systems as well in IMF. And in this context, it's an example of a separation system represented as an IMF model with, in this picture, three aspects: the functional, location, and products. But it might be more aspects indicated by the dot. The functional requirement, the product representation fulfilling the functional requirements, and also the location aspects. Yes, then we are into the digital asset and the full ecosystem and the life cycle perspective. And Ove will take over this one. In the meantime, are there any questions so far? Okay, clear as mud, as we say in the oil and gas industry.
Good, Jann. Now, Mihaly, you have a question, please.
Yeah, very brief question. Thank you for the presentation. It's very exciting. What I wondered, is there any materialization of the alignment between the IMF model and the IDO model?
Yes, we have been working hard on that during the autumn last year, Mihaly. And we have some work still to be covered, and we are debating how to do that in the near future. And I know that the IMF team in the university in Oslo, they are working on the manual as well. So hopefully we will align in the sometime during 2025.
Okay, thanks, Jann.
That's a good question, Mihaly, and it's an important question because the work of aligning IMF and IDO is also based on the pillars that I presented earlier. And it's also coming back to updating the industry standardization and recommended practice that is developed by DNV. So we need to update that also in compliance with IDO as such.
Yes.
What we would like to do now is actually to kind of demonstrate what we have been working on this autumn. Because one thing is the theory of bringing this together using the IMF building blocks as presented by Jann, but we developed some use cases to demonstrate this through a life cycle perspective. So I will take you through some of the use cases we have demonstrating this autumn, and where we actually create some proof of concept that actually IMF and IMF framework based on IDO is working together. So first of all, we need to have a place to kind of work on, and we need to create some libraries as such. This is a very close collaboration with Processor and the original libraries they already have in place. But what we in the beginning saw the need of is actually connecting PCA together with other libraries. So first of all, on the left side here, you see that we need to make sure that we understand those reference data libraries that can take on board the different definitions and other things that comes into play. So that could be what already consist in the PCA libraries, but there could be connection to GeForce, but also what we have demonstrated in this autumn that is very important for when it comes to instruments is the IEC CDD library. So we need all those kind of libraries to kind of be interoperable also within creating the foundation. Then when we now establish IMF types, as explained by Jann, we need to also have a place to publish those IMF types or those templates that actually represent the different equipment or processes or systems as we define. We have worked close with PCA to establish that library to kind of govern those IMF type, maintaining them, make sure that they are in compliance with the IMF framework, but also make sure that there is a possibility to kind of update them and define new IMF type as well. To create content into this library, we had work together with a sub-supplier that started now to define up equipment classes based on those reference data libraries that I explained earlier, and then define up according to the IMF framework. So taking more than 30 equipment classes and defining them up and putting them into the IMF framework, and creating template that can be instantiated by industry actors in all those aspects that we have as a starting point. That means the plant aspect, function aspect, product aspect, location aspect as such. So this is just to have a go to scale it up and make it available for the different industries, IMF type that can be used in different processes. And I think I need to emphasize, because you saw in the beginning, this is done by DISC, and this is mainly oil and gas players. But what we're creating now is agnostic when it comes to industries. Doesn't matter if it's oil and gas or car manufacturing, or it's going to be healthcare or such, or other process industry. We're creating a standard or an IMF framework that can be used across industries, being interoperable across industries. So this vendor has helped us not to scale up and make something available that we can build on. But it's very important also that we now establish those automated quality assurance check. We need to make sure that these IMF types actually are verified to follow the IMF framework as developed together with the actors in the industry. So we need to automate this because this is a huge amount of data that's connected together by terminals as such, but we need to make sure that this is automatically verified so we can take it in use when it's available in the library. So when we have now IMF types in this library available for the industry, this then can be transferred and taken on board to different data platforms in the different industries, and they can map it up to their systems. We our use case was using the engineering companies, our Aker Solutions and Able, demonstrating that they can actually take on board those IMF types that we have defined and modeled up according to the IMF framework, and they have mapped this into their engineering systems. So meaning that they taken out the data set instead of documents, and being able to instantiate those IMF type with information and data. Of course, when they do that, they need also to verify that they are in compliance and that those data set is machine understandable and readable. So we have demonstrated that we can do automatically reasoning and putting some continuous assurance agents as illustrated here, we develop a continuous assurance agent inside DNV to kind of independently verify that you are according to the rules and the requirements around IMF framework. And this goes in between equipment, that goes in between equipment that is belonging to a system and that come into representing as the process that Jann explained that we are putting in, but it goes across aspect as well. Connecting the different aspects is so important, so we understand the different aspects of the equipment and the processes. So what about the suppliers? Yeah. All those people that are making a system or an equipment need also be on the same side of this IMF framework. So what we created in the product aspect is a template. So different suppliers or OEMs can take on board and instantiate with their kind of data set or specification of the equipment. So all those equipment class that we have now produced is available for suppliers to take on board and then create a data set or a data specification of their equipment. This should be kind of replacing the traditional data sheet. So this is kind of one of our objectives, moving from document to data. So creating a model that represents a specific equipment with their functional requirement or specification, and also the equipment itself specification. And then we would like to make those suppliers a data set available for the industry. And to demonstrate this, we have had a close collaboration with Aker in offshore Norway, and make sure that we can publish those equipment data sets and make it available for the industry. It could be any kind of library that can host this kind of IMF data sets. They could be E-class or other libraries that can host it. But just to make sure that we can work together with the different industries, we use this as a use case. And of course, as an engineering company, we would like to check out with those libraries if there is equipment that fulfill our design, so we can develop the design we are using. But it could also be used for the operating companies when they're looking for maintenance or a replacement of equipment, looking for equipment that they would like to replace, see if there is an equipment that is more needed or fulfill other requirements that have developed during time. Our use case looked more into the purchasing process. So when we have a need for purchase some equipment, we would like to specify that purchase order in a way that could actually automate more of the purchasing process as well. So what we demonstrating this autumn is actually that when we have a design that is approved by the operator and engineering company, we would like to go to the market and put a request for quotation of specific equipment. And this data requirements for this purchases order is also based on IMF modeling. So that means that we create a digital data set of requirements when we put together a purchase package. And hence we can go request for quotations for those suppliers that have that kind of equipment, and they will supply or they will put in place their offering based on IMF framework, meaning that we can automate and verify if what equipment fulfill our requirements when it comes to functional aspect and also the plant as such for the equipment. And we can combine those with the product aspects, what is the supplier giving us. And these services could more easily kind of put in place, see what equipment really fulfill our need in this design. And when we have chosen this equipment that actually fulfill our design, this become a part of our bigger asset information model, putting in place instantiated product aspects, data sets that represent a specific equipment. And when I say specific equipment, is very important to understand this is one equipment that has a specific location and a place within a plant, whatever plant that it could be. So it's a very important both for the aspect, but also the properties and attributes and the equipment itself that has persistent IDs. We know where it is located, what function it has, and every aspect of it. So when we have built a plant or built some processes as such, we would like to test this out and make sure that this is actually working according to the specification or design requirements. Our vision is actually if we have creating a fully model that represents something physical that we have built and constructed, we would like to kind of perform a digital commissioning on this. Meaning that we can do commissioning on a digital representation, a digital asset information model. Hence, we can actually carry out not only creating the requirements that we need to check out for the physical build, but also the commissioning itself, saving a lot of time, saving a lot of misunderstanding, and actually discovering something that's not working according to the design specification before we start building it, avoiding rebuild or modification during the process. So when it's fully, sorry, was the wrong place. So when we have commissioned this and it's becoming ready for operation, we need to make sure that we understand the digital representation or a digital asset that actually represent a physical asset. So we do commissioning both on the digital asset and the physical asset. Make sure that these both are actually built and represent each other. And when we have verified that with trusted information models, then we can actually start feeding it with data. Because we need data from the different aspects and the different physical asset instrumentation or equipment to actually make these information models, our asset information models, live. We need to make sure that everything that happens on the physical asset actually is representing in the digital asset. Is it going slower?
It seems like my laptop has problems. Yes, your animation was stopping halfway.
Yeah, but I can explain what's happening here, no problem. So if you can fix it when I'm talking, no problem. Yeah. So if you look on the right side now, it's so important to understand that everything that is collecting by data is validated and verified and have the right quality before we feed it back to the digital representation. Because we would like to sit in the digital asset, trusting that my digital representation actually representing something in the physical asset. Because otherwise, I can make wrong decisions based on the wrong requirements or the foundation. So if you look at the right side, that's some very important things illustrated there. So everything we inspect and collect of data by human being is also vital data that we need to feed back to the digital representation. So having an inspector reading something out in the field or whatever there is, we need to make sure that that data is contextualized and readable, then we can feed back to the asset information model. And then every change we do on a physical asset, it doesn't matter what it is, we need to make sure that we have management of change process in place. We need to make sure that we actually have a risk assessment of every change. And this is a very important part because as we do a management of change process today, we normally have written in our procedures saying if you do something like for like, if you change a pump with the same brand, with the same functionality, a pump, you don't need to do a risk assessment or an MOC process. We need to change that kind of procedure and behavior, because whatever you change in this pump will affect the asset information model or the digital representation. Because this pump, we are collecting data on this pump and it degrades over time. It performs less and less. And hence that's the reason why we maybe like to shift the pump with a newer pump. That functionality that is degrading over time is also data that is fed back to the digital asset information model. So because we would like to know that my model is actually representing the physical asset as is when I need it. So we need to make sure that we have a risk assessment, what we do on the physical asset actually represent in the digital asset. The other thing is, of course, all the sensors, all the instrumentation we're doing that, we need to make sure that we understand the quality of the sensor itself. Because we know that the sensor can drifting or they can be out of calibration as such. So all that things is also need to be fed back to the digital representation. So we understand the full picture and the truth around the health of the physical asset. So we need to have in place what we call a continuous assurance agent, both for quality, but also monitoring every change that can happen. But that goes both for the physical asset and the digital asset. Don't forget, we're doing a lot of maintenance and modifications, new firmware, new features in the digital assets as well. We need to make sure that we risk assess whatever we do in the digital asset, so we maintain that trustworthiness when it comes to trusting the digital representation of the physical asset. That's the only place where we can really trust a digital twin or a digital asset. So, in the bottom of this digital asset, what we have starting the journey and standardizing is creating those interoperable asset information model based on IMF. And IMF need to have those three pillars that I mentioned in the beginning. And one of the most important in our view for this community is make sure that we have the OBI and IDO standard developed, and make sure that, as Mihaela asked about, that this is also in compliance with the IMF is compliant with that IDO standard. So if now Jann has fixed his computer,
yeah,
I should be able to move to the next slide, or
yes,
you can move to the next slide.
I can do it as well, yes.
Yep. And we could open up for questions.
There are two questions in the chat. If you can read it, you can.
Yes, I see Torbjørn Holm have raised the question. Can you explain what is the tag, the part model, and the equipment?
I can maybe start, Jann, and you kind of add on. So let's start with the tag itself. I guess as a kind of a part of the identifier is in the IMF is an attribute itself. So tag has some information, but it doesn't have all the information we need when we create an IMF type representing an equipment. And I guess, and Jann, you add on the part model and the equipment. When we look at equipment, the equipment itself contains a lot of parts. So we break down all equipment into the smallest pieces as we can and model up those based on the definition in the libraries. So that means that we're taking everything apart and going back down as far as we are able to do, define it up again, connecting those parts that belong to equipment with the terminals and explaining those in the different aspects. Jann, if you have something to add on that.
Yeah, I can add, because Torbjørn added a little bit more text. He mentioned that it's important that tag, equipment and part models are aligned with IDO. So what you mean is clear. So that's fine, Torbjørn. Thank you. The next question, I think it's from you, Andreas. In the architecture, you have presented a lot of interface are needed. This is and will be reality. My question is, how is it ensured that these interfaces are standardized on the data level, and how is ensured that the same data is well maintained over the whole life cycle? Andreas, are you thinking about the terminals in this context?
Yes, could be, but for me, at the end, the data should be exchanged. What was mentioned is the point of the interoperability,
Yes.
and which is shown here in this slide as well. So, and with this, you need to understand that the semantic behind the data. So for me, it is more which rules will be implemented that you really can trust, because you understand the different aspects and so on and so forth. So without any rule behind, you will not have a standardized interface and really a real interoperability. So you have different interfaces where you have different data and so on and so forth. And how is ensured at the end that, because IDO leaves a lot things open. It is not finally defined. So some details are not defined in IDO. So it is not enough really having IDO as upper ontology or something like this. There is more needed. And I would like to know how this more looks like, if you have already defined it. If not, who will define it? Is it on the roadmap to define it?
Absolutely. Yeah, we are working on these elements, Andreas, and we are testing it out and see how our models is working as well. We have actually established a model in our databases today that is compliant with the IMF structure and has its connections. So we are testing it out. We do not have the answers on all the questions, but we are honing in on them.
And they will be documented and then made public. Will this become then a publicly available standard or something like this?
Everything we are experiencing and learning will be fed back to the IMF manual and the IMF library found in PostCaesar. And of course, also there is a recommended practice by Veritas that is available in the market, and those needs to be upgraded and modernized as we get more experience.
Following the order the questions came in, I think Arne, you raised your hand, so if we follow the order and it came in.
Yes. Could you skip one slide back, please?
Yes, I can.
I've seen most of these drafts and diagrams before, but I don't recognize this continuous assurance agent. Yeah. And it also popped into the diagram a couple of times earlier, where it interacted with both the PCA libraries and the IMF type libraries.
Yes.
And since I have, say, a role in the management and construction of those libraries, yeah, I'm kind of wondering, what is it?
I can answer that, no problem, Anna. This is just an agent that we have developed that could fulfill a role of automatic verification and validation. So it's in independent quality monitoring of the quality of the data or the models as such. So we just illustrate that we need to put in place some agent that actually can automate these verifications.
It's a product made by someone?
Yeah, it's a product, as you see, is made by DNV.
We already have verification in the library.
Yeah, I know. But this is just an illustration of what we need to have in place, and we just put that as an example that could be the agent actually fulfill your role.
Okay, I understand.
And we have used this for the use case and demonstrate that it's capable of doing it.
Yeah.
Okay.
Excellent.
Yeah.
And then just fulfill Nils, because one of the question in the maybe belong also what Arne asked about. Yes, I guess the answer on is the PCA libraries open and available? I would say, I guess you will answer that as a yes.
Absolutely. Yeah.
And what Jann tried to say, whatever we do in this, and then all the use cases, all the development of the IMF manual and as such, everything should be published through PCA, made available for the different industries.
And there is another question also, is physical asset the same as equipment?
Again, this is our use case. There could be any asset. And remember, an asset is just something that is valuable for somebody. So there could be a process, there could be a equipment, as I asked about. There could be a physical thing, or it could be something as a process.
But an equipment is a physical asset.
Yeah.
Yes.
But the other way around is not. You cannot have other physical assets as well.
Yeah. But this illustration and this use case is just about you have something that actually is in the real world, so you could call it real world, what's happening out there, and you what we are trying now to create a digital representation of what happens in the real world.
And there is another question also, is the IMF domain model in OWL? So how is the domain model written? Is it in OWL or is it in another representation?
I don't know what the experts would say to that, but we at least want to make the models, the OWL, IDO, OBI, OWL-based model, as closely connected to the IMF as possible.
Arne, you had your hand raised.
Yeah, I'm sorry, I'm unable to lower my hand for some reason. But I can also give a small detail about the IMF ontology is available as an OWL ontology. For some reason, I can't write in the chat, so I can't supply the links. But if you go to imfid.org, follow the links to the version IRI, you will find a link to the OWL ontology for IMF. I think it's the one that is represented in the version 0.30 of the IMF manual.
Okay. I thought about it just before the meeting. We should have had an end slide pointing to some resources that would be valuable for readers going forward. So maybe we should take that action after the meeting.
Yes, I think we should. There are some more questions maybe.
Yeah, I see a question from Temmen. Is ISO 15926 Part 4 the central RDL? It is one of the central RDLs. As Ove mentioned, yes, the Part 4 is an important one. The CDD is an important one. The GFOS is an important one. So we have several.
Time is running out, so I think if not any really burning question, I would like to use the last minute to say what is coming next. And is that okay?
That's
Jann?
okay. Absolutely.
So we are. This is the 14th of February, and next Friday we have the winter break in Norway, so we will have no session for next Friday. 2 weeks from now, it will be a deep dive into DXP version 1.4, and I think the follow-on will also be denoted to DXP. Maybe we have questions as an answer, or maybe we do DXP plant. I need to discuss that with the DXP people who are going to present in 2 weeks from now. Yeah. And I think you are right, Jann. We need to put more links into here. I just want to point out one thing. I get actually several questions of where to find the recordings for this sessions, and they are on the second slide. There are 2 places. You can go to the PCA YouTube, or for those who are members of the FPVN project, you can also find them on the cloud for FPVN.
Yeah, and there is a lot of fantastic good material there.
Yes, and for the presentations, we need to do some work to get the presentations available without going into the recordings. That is a little bit more difficult, simply because there are not all the presenters who have made slides. Some of the presentations is just off what is available on the web, and from different sources on the web, so that is more difficult to get together. We will see what we can get done. That was what I had. Thank you so much, Jann. Thank you so much, Ove.
Thank you all.
And hope to see you all again 2 weeks from now.
Have a nice weekend.
Thank you very
Thank
much.
you.
Bye-bye.
Bye.
Weekend.
Bye.
Thank you.
Bye.
Thank you. Bye.